Hello and welcome to the 17th episode of Histo Helpers. My name is Taylor Christ and today we're going to be exploring the endocrine system. Our objectives today will be to identify the three parts of the pituitary gland, to tell the difference between the cell types of the pituitary gland, to identify the components of the thyroid and parathyroid glands, to identify the different zones of the adrenal cortex, to examine the adrenal medulla, to identify the islets of Langerhans of the pancreas, and to identify histological components of the pineal gland. Before we get started with the pituitary gland, let's do a quick conceptual review of its functions. The pituitary gland is a pea-sized endocrine gland that protrudes from the hypothalamus at the base of the brain and rests in the hypophyseal fossa of the sphenoid bone. It is the master gland of the endocrine system because it is involved in the regulation of many homeostatic mechanisms in the body. The posterior pituitary, also called the pars nervosa or neurohypophysis, is seen on the left side of this diagram. It is composed of a collection of neuronal projections from the hypothalamus and functions to store and secrete oxytocin, an antidiuretic hormone, or vasopressin. The anterior pituitary, also called the adenohypophysis, or pars distalis, is seen on the right side. It synthesizes and secretes adrenocorticotropic hormone, endorphins, follicle-stimulating hormone, growth hormone, luteinizing hormone, prolactin, and thyroid-stimulating hormone. Lastly, the third part of the pituitary gland is the glandular pars intermedia, forming the boundary between the anterior and posterior lobes. I believe our resident mnemonics expert, Garrison Glavich, has come up with a great tool to help you remember the hormones of the anterior pituitary. Is that right, Garrison?
That is correct, Taylor. I'm going to take you all on a trip to High Yield City. Population, you. We're going to take this mess of hormones and mnemonicize them. When we do, we get F, L, A, T, P, E, and G, which spells flat peg. You may ask yourself, what's a flat peg? But that would be low yield and untestable. Remember that the anterior pituitary secretes flat peg.
Both the anterior and posterior pituitary glands are under the control of the hypothalamus, but in different ways. The anterior pituitary synthesizes its own hormones and is regulated by the hypothalamic hormones that travel down the hypothalamo-hypophyseal portal vessels to the anterior pituitary. The posterior pituitary, on the other hand, is not glandular and instead functions to store and secrete hypothalamic hormones. Now let's look at some histology. Slide 259 is a section of the pituitary gland stained with H&E. The anterior lobe is indicated by the green arrow. The posterior lobe is indicated by the orange arrow, and the intermediate lobe is indicated by the blue arrow. First, let's zoom in and take a better look at the anterior lobe. This large bulbous portion of the anterior lobe is called the pars distalis. It is heavily perfused by leaky sinusoidal capillaries and is composed of three basic cell types: acidophilic cells, basophilic cells, and chromophobic cells. The acidophils and basophils are considered chromophilic, which in histology means that they stain easily. The chromophobes, on the other hand, do not stain with H&E. I have indicated several of the acidophilic cells with yellow arrows. Cells that stain acidophilic include the somatotropes, lactotropes, and corticotropes. You can also see some basophilic cells, which are indicated by the light blue arrows. The cells that stain basophilic include gonadotropes and thyrotropes. I have also indicated a few chromophobes with pink arrows. These cells are typically smaller, with cytoplasm that does not stain well. The function of these cells is not well understood. Now let's zoom into the right side of the slide to take a look at the posterior lobe. The posterior lobe of the pituitary gland is not a true endocrine gland because it simply stores and releases the hypothalamic hormones oxytocin and antidiuretic hormone into the bloodstream. Make sure you can identify pituocytes, which are modified glial cells with round or oval-shaped nuclei that assist with the storage and release of these neurohypophyseal hormones. I have indicated a few of these cells with the green arrows. Over here, at the red arrows, you can see some herring bodies, which are the terminal ends of the hypothalamic axons where the neurosecretory hormones are stored prior to release. Now, let's take a look at the pars intermedia. It is mostly home to chromophobic cells, basophilic cells, and these characteristic colloid follicles, which are lined by cuboidal epithelial cells. These follicles are embryological remnants of Rathke's pouch. Let's take a quick look at slide 151, which is another section of the pituitary gland stained with H&E. This slide more clearly shows the pars tuberalis, which is a highly vascular component of the anterior lobe that wraps around the pituitary stalk. The pars tuberalis is indicated by the large green arrow. To orient you, the pars distalis is indicated to the left by the blue arrow, the pars intermedia by the orange arrow, and the pars nervosa by the pink arrow. We're now looking at slide 154, which is the section of the thyroid gland stained with H&E. Take a look at this thyroid gland. It is lined by a connective tissue capsule with an extensive set of trabeculae that invaginate into the parenchyma of the organ. The capsule is indicated by the green arrow, with the trabeculae invaginating into the parenchyma indicated by the red arrow. Notice the numerous thyroid follicles filled with colloid. I have indicated a few follicles with yellow arrows. They are lined by epithelium ranging from simple cuboidal to almost columnar. As a general rule of thumb, the taller or more columnar the follicular cells, the more active the thyroid is. The key component of colloid is thyroid globulin, which is produced by the follicular cells. It is essential for the production of thyroid hormones T3 and T4. The interstitium of the thyroid gland is home to an extensive capillary network in the parafollicular cells. I have indicated several groups of parafollicular cells by the blue arrows. These lightly staining cells, also known as C cells, secrete calcitonin into the bloodstream. What does calcitonin do exactly? I think that's a job best left for our parafolliculologist, Joyce Ann Compton.
Thanks, guys. Glad to be here. These parafollicular cells will respond to high serum calcium levels by secreting calcitonin, which is a polypeptide hormone that helps lower serum calcium. It does this by decreasing the intestinal absorption of calcium, by increasing the activity of osteoblasts, by decreasing the activity of osteoclasts, and by preventing the reabsorption of calcium in the kidney. I like to recall the effects of calcitonin by remembering the phrase, calcitonin keeps the bone in. Its combined effects counteract parathyroid hormone, which I think you guys will be talking about next.
That's right, Joyce Ann. Thanks a lot for your help.
My pleasure.
We've now transitioned to slide 158, which is a section of the parathyroid gland stained with H&E. Here you can see a section of the parathyroid gland indicated by the large yellow arrow. Notice how it is surrounded by thyroid tissue. The parathyroid gland has its own connective tissue capsule with invaginating trabeculae and functions to secrete parathyroid hormone, or PTH, into the bloodstream. Like Joyce Ann mentioned, PTH does the opposite of calcitonin, increasing serum calcium levels by stimulating bone resorption, stimulating calcium reabsorption in the kidneys, and enhancing intestinal absorption of calcium from the gut. Let's glance at slide 261, which is another section of the parathyroid gland stained with H&E. This slide more clearly shows the parenchyma of the parathyroid. The chief cells are indicated by blue arrows and are the cells that secrete parathyroid hormone, or PTH. They are smaller and stain lightly. Over here, the darker acidophilic staining clusters of cells, indicated by the orange arrows, are the mysterious oxyphil cells. Their physiological function has yet to be fully discovered. We've moved on to slide 160, which is a section of the adrenal gland stained with H&E. The adrenal, or suprarenal gland, is a multifunctional endocrine organ encased in a connective tissue capsule. The outer adrenal cortex is spanned by the green line, with the extent of the inner adrenal medulla spanned by the orange line. As I zoom in, the cortex is organized into 3 distinct layers. For all you ladies out there, today is your lucky day. We managed to grab our dating expert, Julian Henderson, to discuss the adrenal cortex.
Thanks, fellas. I like to use the layers of the adrenal cortex as a guide to the perfect date. The outermost layer is the zona glomerulosa, spanned by the blue line. It secretes mineralocorticoids like aldosterone, which represents the salty appetizer that gets the date started. Next, you have the zona fasciculata, spanned by the red line. The zona fasciculata secretes glucocorticoids and represents the sweet dessert at the end of the meal. Lastly, you have your zona reticularis, spanned by the yellow line, which secretes sex hormones like androgens. If you've done your job properly, these hormones should be pretty high at the end of the night.
So to recap, the layers of the adrenal cortex can be remembered by salty, sweet, and sex. Thanks, Julian.
Happy to help.
Keep in mind that sinusoidal capillaries, indicated by the pointer, line the cords of cells making up these cortical layers. The adrenal medulla is the deepest layer of the adrenal gland. If I zoom in, you can see the chromaffin cells indicated by the purple arrows. These large, lightly staining cells are of neural crest origin and secrete catecholamines like epinephrine into the bloodstream. These cells are in fact modified neurons that release their catecholamines in response to preganglionic sympathetic neurons synapsing directly onto them. You wouldn't be crazy if you thought that the adrenal medulla looked a lot like the parathyroid gland, so do your best to keep these straight. We're now looking at slide 250, which is a section of the pancreas stained with H&E. You've already studied the pancreas, but let's take another look at the islets of Langerhans, several of which are indicated by the green arrows. These islets of Langerhans contribute the endocrine function of the pancreas and are composed of 3 important cell types: alpha cells that produce glucagon, beta cells that produce insulin, and delta cells that secrete somatostatin. Note that with H&E, you can't tell which cell is which. Take a look at this pineal gland stained with H&E. This slide is not in our slide hosting collection, but we've included the link later on. The pineal gland is a small pine cone-shaped endocrine gland situated deep in the brain. It is responsible for synthesizing melatonin, which plays a role in regulating the circadian rhythm. It is surrounded by a connective tissue capsule, which is seen at the yellow arrow. Trabecula can be seen extending into the organ's parenchyma, as indicated by the green arrow. As I zoom in, you can see the round nuclei of the lightly staining pinealocytes, which are indicated by the red arrows. Astrocytes, on the other hand, are smaller and have more darkly staining nuclei. I indicated some astrocytes with orange arrows for comparison. Lastly, I pointed out some corpora arenacea, or brain sand, with light blue arrows. The function of these calcified structures is unknown, but they are known to increase with age. Well, that's a wrap for episode 17. I hope this introduction to endocrine histology was helpful for you, and I really hope you join us next time for a special sensory, stimulating look at the eye and ear, recorded by our beloved Histo Helpers editor, Raheem the Prince Nani. As always, thank you for watching